14K, we are now doing tan graphs. So you've done sine, cosine graphs. Tan graphs is much easier. And I'll tell you why. You see a tan graph, if you just think about a unit circle, you see what's nice about a unit circle that you can tell why tan graph has these properties. Now let's have a look. Tan represents what again? X, Y, or gradient? Gradient. Now, when you start off at 0, what gradient is this line? What's the gradient of this line? 0. So you start off at 0. Does that make sense? That's why the graph starts off at 0. See right there? When it's 0, it starts at 0. Yeah? So this point, when it's 0, starts at 0. But then let's have a look at what happens. As I rotate around the circle, so as I rotate, so from here, my gradient is positive, but it's increasing and increasing and increasing. The closer I get to 90 degrees, what is my gradient approaching? What kind of a gradient is this? Undefined. But what does that mean? Let's think on a logical sense. We said it's getting bigger and bigger and bigger because it's positive, 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 positive. But you get to a positive where it's positive infinity because it's undefined. It just keeps going, right? So at some point, the line just keeps going larger, 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 larger. So at 89.9999 degrees, there is still a gradient. The gradient is just very steep. And then until you get exactly 90.0, that there is no answer to it. But if there's no answer to it, that means that it's an asymptote. It never reaches that point. So if you look at the graph, you see that? That's what's happening. That's the first quadrant. The first quadrant is just showing increasing, positive, 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 positive. And not until you hit exactly 90 degrees, that's when it's undefined. But before that, just at 89.999999, you still have a gradient. It's just very large. So why is this nice? There's no amplitude. Remember, sine and cosine, you have to find the maximum, find the minimum, know where the middle line is. You don't need to know that anymore. You just need to find the asymptote. Once you know the asymptote, it goes up. But how do you find the asymptote? It's every time it's 90 degrees. But in the unit circle, when is it going to be a vertical line? It's at pi on 2. It's at pi on 2. It's at 3 pi on 2. Because that's 1 pi on 2, that's 2 pi on 2, that's 3 pi on 2, this is 4 pi on 2, then you get back here, that's now 5 pi on 2, then 6 pi, then 7 pi on 2, there's a pattern. Oh, sorry, not 12. Every time you have a pi on 2, if it's a factor of pi on 2, it's going to be an asymptote for a tan graph. So this is nice, because all you need is just the asymptotes and you can sketch the graphs. Now, for those who don't even understand how to read a unit circle, there's a formula for you to actually work out all the asymptotes. Looks crazy, but if you really think about it, what is this saying? When you double K, if you double a number, what does it guarantee? Massey. Even. Every time you double a number, it's always going to be even. Because if you have two pairs, then it's even. So this is saying you're always going to get an even number. Plus 1 will make it odd. So this is just saying the numerator is an always odd pi over 2 and multiples of 2n because it could change a dilation. The n is a dilation. It can change how thin or how wide number of cycles you're going to get. So your asymptote is just saying every odd pi on 2. That's literally what it's saying. This is saying find odd because it was 1 pi on 2, 3 pi on 2, 5 pi on 2, 7 pi on 2, 9 pi on 2. All of those are going to give you undefined. So every odd pi over 2, and it's just the dilation. So all you have to do is in a graph, if you can work out where the asymptotes are, that's your tan graph. It sits between those two. There is no there's no maximum or minimum. That's why it's easy to sketch. But what's also special, this is one cycle, meaning one period. How many x-intercepts can you get in this cycle based on this graph? 1. Whereas sine and cosine, you can get 2. And it makes it really confusing because you have to always work out for 2. This one, there's only 1. So that means as soon as you find the first one, you can find the rest. The rest is just adding on a period. But let's think about tan now. Why is tan so special as well? Well, how long does it take to go from undefined to undefined again? How long does it take? So here's your vertical line, undefined. How long does it take to rotate to get to undefined again? What's the angle? From here to here. Pi. It's 180 degrees. That's why, unlike sine and cosine, it's not 2 pi to get back to the starting point again. It's only 1 pi. That's why your period is a different formula. Pi divided by n. So, based on this understanding, I've given you a rule to find your asymptotes. Once you find the first x-intercept, which you've been practicing in 14G, you just add on the period. Just add 1, you get the next one. Add 1, you get the next one. But if you have all the asymptotes, it's so much easier to sketch compared to sine and cosine because you just draw these asymptotes and you just do this. Once you find the first x-intercept, just add on pi, and you get them all. Let's tie it in together. Let's do an example. Here we go. So period. Remember, period of a graph is pi and n, so fill that in. X-axis intercept is equal to, it's pretty much every, well, I should do n over here so you can see. But essentially, it is the tan inverse of 0, which is 0 or pi. So it's n pi, every n pi. I'll just do that for now. All right, let's do an example so that you can see how easy it is to sketch tan graphs. We're just going to do the first page. The next page has some really more intense addition to it, but same idea. Yeah, much easier to sketch. Let's do this one. Tan of x. Now remember, tan graphs have no what? Starting with A. No amplitude, okay? So you don't have to worry. Or asymptote. Well, yes, they have asymptotes, but they have no amplitude. Why don't they have amplitude? No maximum or minimum. That's special. That means there's 2. Don't confuse that with sine and cosine. Right? Don't say max 2, minimum 2. That's only for sine and cosine. So if there's no amplitude, then the 2, you don't even have to worry about the 2. Who cares? 2 doesn't do anything. We just know it stretches it. But when you're sketching it, no one knows what kind of dilation it is. So let's find out asymptotes. Asymptotes. I just gave you a rule. What's the rule for the asymptote? How do you find the asymptotes again? 2k plus 1. So 2k plus 1 makes it odd. Times pi divided by 2. So pi on 2. That's for every pi on 2. But n. What's our n in this case? 1. N is the same thing. The coefficient of x, so n equals 1. And so therefore, this is your formula to work out all your asymptotes. It's 2k plus 1 pi over 2. Now what's k? You make it up. You sub in as many numbers as you want until you fit this domain. So let's make it up. If k was 0, then your first asymptote would be 1 pi on 2. If k was 1, so I'd write if. We're just testing. You can try negative ones as well. They're just integers. Yeah, try whatever whole number k that you can come up with. So if k was equal to 1, then you have 2 times 1 plus 1. So it becomes 2 times 1 plus 1 pi on 2. But hopefully you realize it's just every odd pi. So it's just 1 and that's 3. So it ends up being 3 pi and 2. But at this point, do you really need to use the formula to work out all the rest? No, because this is all we're doing. As soon as you know the first one, every time you get the first one, you can work out the rest. Here we go, pi on 2. I've already drawn a grid for you, so I'm going to do it here. Here's my first asymptote. So here's my asymptote. This is when x is equal to pi and 2. You found it when you did k equals 0. You got your first asymptote. Now, if you want to find the rest, you don't have to sub k equals 1, k equals 2, k equals 3, or k equals -1. You know what you could have done? Because they all are cycles, it's a period of whatever the period is, right? So if you want to find the next one, just add on and minus a period. Now let's work out the period. What's the period for pi, or this tan function? It's pi on n. N is 1. So the period for this graph is just pi. But if it's pi, this is your first asymptote. If you want to get to the next asymptote, just subtract pi. If you want to get this way, add pi. That's all it is. Just add pi minus pi. So from here, if you think about it, pi on 2 plus pi, isn't that just saying half plus 1? And half plus 1 is 3/2. And that's what we had over here. But you didn't have to use a rule to get that. You can literally just get one asymptote by subbing k equals 0 and just add the period, because the period is what's special about it. It keeps coming back to the same cycle. So you just repeat it. So add pi to get to the next one. So here we go. If you add pi, we get 3 pi on 2, which is this direction. So 3 pi on 2. If you subtract pi, what's pi on 2 subtract pi? So half take away 1. What's half take away 1? Oh my God, are we struggling? What's half take away 1? Oh, you guys can figure that out. Use the CAS. I'm just going to write it here now. -1/2, for God's sakes. Subtract. Yeah, subtract pi. And here's your next asymptote. Once you have the asymptote, it's really easy to sketch. Here we go. We've got the asymptote. So we know the graph should look something like this. What you don't know is what the x-intercept is. But logically, I already know what the x-intercept is just by looking at it. But let's say you didn't know that. How do you find the x-intercept? Well, x-intercept is just when y equals 0. So this is what you've been training to do. Y equals 2 tan of x. Let y equal to 0 to find the x-intercept. 2 tan of x. And you notice here that when you divide both sides by 2, you get 0 is equal to tan of x. And the nice thing is you only need one solution. You don't actually need two. Right here, to find x, you do tan inverse of both sides. So tan inverse of 0, so you're asking, go through your exact values. Tan of what will give you 0? 0. You only need one answer. But the reason why I said I don't need to do this calculation is you can just look at the unit circle. This graph did not move left or right, didn't move up or down, so I know that the center is still at 0. So hence I knew it was 0 already, but just in case you didn't know, that's how you find it. But why do you only need one? Because once you know one, you can find the rest. How do you find the rest? Add on pi to get there. Subtract pi to get the other one. That's all you got to do. Subtract pi, add pi. So if you think about it, your first intercept, remember the interval was from -pi to pi. You found the first one 0. If you want to find the next intercepts, just add on the period. So add pi or subtract pi, and it turns out -pi, pi, and 0 are my x-intercepts. So here we go. X-intercept at -pi 0, x-intercept at pi 0, and if you follow the graph would usually look like this. As a cycle, so I'm just drawing from infinity, so that means high infinity down, and just follow the cycle. But isn't that so much quicker and easier than sine and cosine? You didn't have to find the max, didn't have to find the minimum, you just literally find one intercept, one asymptote. Add on the period. That's all you're going to do. Okay, so for all graphs, no matter which one I give to you, you are just finding one x-intercept, one asymptote, add and subtract the period. And that will give you the boundaries to sketching one. Let's do the next one. Over there. Just so you can get a feel of it. Here we go. Same thing again. Let's find out asymptotes. You just need one. Currently, n is equal to 2. So asymptote is 2k plus 1 pi over 2 times 2. So you got 2k plus 1 pi over 4. Right? 2k plus 1 pi over 4. Because n is currently 2. Find one asymptote. Doesn't matter which one. I like the best one to use k equals 0. If k equals 0, your first asymptote will be pi and 4. So where's pi and 4? Let's have a look at the diagram. So I've just worked out your first asymptote. If you want to find all your asymptotes right now, add or subtract the period. What's the period equal to? Pi divided by n. But since n is 2, your period must just be pi and 2. So now if you've got your first asymptote, which is when x equals to pi on 4, let's find where pi and 4 is. Here's pi and 2, pi and 4 is halfway. So halfway could probably be, actually it's not exactly there. It's probably better had I not given you this grid actually. I'll just draw it on the side. Here, pi and 4. You want to find the next asymptotes? Add or subtract your period. Here we go. So from here, add pi and 2 or subtract pi and 2. Let's do a bit of fractions. What's pi and 4 plus pi and 2? What does that give you? 3 pi and 4, right? So you can just change it to 2 pi on 4, add on an extra 2. If you add an extra 2, this is what my asymptote looks like. This is now at 3 pi on 4, add an extra 2, 5 pi on 4, add an extra 2, 7 pi on 4. Can you see what I'm doing? I'm just drawing the boundaries. And if I subtract backwards, that's 1/4. So take away 2 gives you now negative pi on 4. Subtract 2 again. You get negative 3 pi on 4. But I can keep going and going. And now if you were to sketch the graph, what type of tan graph do you have? It's a positive tan graph. It's not negative. Here we go. Draw the graph in. There we go. I got my asymptotes in. I've got my graph. But there is a mistake here. What have I not accounted for? Yeah. -1, what does -1 do to the graph again? Down by 1. So all of these x coordinates or x intercepts shifted down by 1. That's it. This all shifts down by 1. So if you shift it down by 1, this is what it looks like. Down by 1, down by 1, down by 1. So here's my new set of graphs. They just follow the same pattern. I shifted down by 1. Everything's gone down by 1. So here we go. -1. So it was originally on the x-axis when you drew it, but because it shifted down by 1, I just shifted the center down. Shifted down by 1, shifted all down by 1. The only thing I'm missing now is find x-intercepts. And you do the same thing again. So y equal to 0, move everything across, and you sketch. But what I'm trying to illustrate at this point, why is this easier to do, is because you just got to find one intercept and one asymptote. Now, I'm aware that we are running out of time. So next session, that's what I'm going to cover again. I'll give you some more examples to do. But hopefully you can see finding a tan graph is so much easier than a sine and a cosine. Okay, I'm going to stop the video there for today.